So let's talk about chain type and horsepower. So the first we have here is a 404 chain, which is a full comp, and full comp is not competition, it's full complement. And so on a full comp chain, you've got a tooth, a link, a tooth, a link, and a tooth. So you have a left, a right, or a link and a right, and a link and a left, and a link and a right. And so that's the most teeth you'll have on a chain. And then the next type is semi-skip. And so on a semi-skip, you've got a cutting tooth and a link and a cutting tooth, and then two links and a cutting tooth, and one link and a cutting tooth. So you got a right, a link, a left, two links, a right, one link, and a left, and then two links in the next set of teeth, and so on. And so the next type is the full skip. And so on the full skip, you've got a right, two links, a left, two links, and a right, two links, and a left, and so on. And so why that matters is if you have fewer teeth per inch, you can run a longer bar on your saw and have the same amount of teeth on it as a 404 chain, or a full comp chain, on a shorter bar. That way you can run a longer bar and have the same cutting load on the saw, and so you can cut bigger wood, whatever, and not overwork your saw. And so I kind of wanted to compare this to a gear ratio on a vehicle or whatever to kind of frame the idea. And so to get a gear ratio, you divide the big gear by the little gear. And so if you have 98 teeth on the big gear and 24 teeth on the little gear, you have a gear ratio of 4.08 to 1, or the little gear will rotate 4.08 times per one revolution of the big gear. And so because we don't have a gear reduction system on the saw, I kind of wanted to compare this to the RPM of the saw. And so first, to kind of frame the idea of horsepower per tooth, like on a circle saw sawmill, the general rule is kind of 2 horsepower per tooth on the saw. So if you have 50 teeth on the blade, you have a 100 horse engine running it, or 100 horse electric motor or whatever. So to kind of frame that idea on a chainsaw, I'm just going to use 5 horsepower as kind of your, entry level pro grade saw, and you can kind of figure it out from there. So the bar on this saw that it has the full comp on is a 28-inch bar, and the bar goes by drivers, but drivers don't necessarily relate directly to the cutting teeth. And so this particular saw with a full skip chain has 30 cutting teeth. And so if you take 5 horsepower divided by 30 cutting teeth, that gives you 0.16 horsepower per tooth. And so I've got the same chain in semi-skip with the same bar, and so that's 5 horsepower divided by 36 teeth. That gives you 1.38 horsepower per tooth. And so it kind of gives you an idea of the reduction in horsepower per tooth just by adding more teeth. And so the other way to look at that would be RPMs of the saw in the cut. And so if you take 10,000 RPMs in the cut divided by 60 seconds, that gives you 166.66 revolutions per second. And so if you divide your revolutions per second by 7-tooth sprocket, that gives you 23.8 revolutions per second per tooth. And then if you do the same for an 8-tooth sprocket, that gives you 20.83 revolutions per second per tooth. And so you can see the mechanical difference, the mechanical advantage difference per tooth in the RPMs. And so like a 460, a steel 460 with a 7-tooth, almost all saws come factory with a 7-tooth because they cut pretty good that way. You can go up to an 8-tooth, and some of the bigger saws will, like an 066 or something in that class, will usually run a 8-tooth pretty well. Like a 460 with an 8-tooth, you might have to put a dual port muffler on it, and then it'll run an 8-tooth pretty well. Otherwise, if you get into bigger wood, it'll fall on his face, So the other way to think about this is you can change your sprocket, or you can change the chain type, or both. And so if you're going to run a longer bar because you're in bigger wood, you might run a full skip chain on a longer bar to do the same thing full comp would on a shorter bar. And if you have the horsepower in the saw, you can make up for that by going to an 8-tooth sprocket. So you're turning a full skip chain faster to make up for having less teeth per inch. And so you can kind of fine tune the performance of your saw and where it likes to cut by, adjusting the chain type and or the sprocket size. And so I just kind of wanted to frame that idea because I haven't seen any videos on that, on an intelligent conversation on chain type and why it matters, and then being able to kind of explain why that matters in a mechanical way where you can see an actual comparison without just kind of throwing out a, this cuts faster, this cuts better, whatever. And so if you guys like it, want to see something else, questions, whatever, hit me up in the comments, and I'll answer it as fast as I can get to it. So hope that makes sense.